Okay, so I just want to briefly mention the binomial theorem, but before I do that, we have to talk about a definition. So, definition, n choose k, red, n choose k, is equal to, is defined. So if you see this, n choose k, what it means is n factorial all over n minus k factorial times k factorial. Okay, what is this useful for? This seems so random. Actually, this represents the number of ways to choose k objects from a set of n. So let me give you an example. Here's a question. I have, oops, what's wrong with my, just a moment. I have 4 friends and want to invite 3 to a party. How many ways can I do this? And how many ways can I do this? So let me just give you an example. So I have friends, their names are A, B, C, and D. Whatever, it doesn't matter. And to choose 3 of them would look something like this. So I'm going to invite A, B, and D. Okay? And that's actually the same as me inviting B, A, and D. Okay? That's the same choice. That's the same guest list so far as we're concerned. But, but that's not the same as C, D, and B. Okay? So how many guest lists do I have? It's actually pretty difficult. It would be pretty difficult to sit down and count them. And in general, it's nice that we have a formula for numbers that are even bigger than this, like 17 and 3. I could do that. But the way we would do this, the answer would be 4 choose 3, because I have 4 objects and I want to choose 3 of them. And that's going to be 4 factorial all over 4 minus 3 factorial times 3 factorial. So let's see, what is this equal to? This is 4 factorial all over 1 factorial, 3 factorial. That's 4 times 3 times 2 times 1 all over 1 times 3 times 2 times 1. Okay? So in case you're not quite sure, 1 factorial is just 1. Right? And 3 factorial is just 3 times 2 times 1. Okay. So what happens? I can start simplifying. 3's cancel, 2 cancels, 1 always cancels. That's equal to 4. Okay, so there are 4 ways for me to invite 3 people to a party. And that makes sense if you think about it. It makes sense because what I'm saying is that inviting 3 people to a party is the same as not inviting one person to a party in this case, right? So how many ways can I not invite one of 4 of my friends? Well, there are 4 ways, right? I could not invite A, I could not invite B, I could not invite C, or I could not invite D. So there are 4 ways. Okay, good. Good. You'll have more practice with this later, but I want to show you something very interesting. It's called Pascal's triangle. So Pascal's triangle, sorry, just a moment here. Something's wrong with my, Here we go. Okay, there we are. So Pascal's triangle looks like this. 1, 1. Okay, so, and you can keep going like this. You might want to pause the video and try to figure out, okay, what's the next row? So I'll give you a second to do that. All right, here's the answer. The answer is, you start with 1s on the sides, and to get the next element, Here, you just look at the above two elements. So 1 plus 4 is 5. So that's going to be 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. All right? Well, what's the point of this? Actually, as it turns out, this can tell you n choose k. So let me make one more convention. We'll call this the 0th row, or row 0. Okay. This is row 1. This is row 2. This is row 3. And so on and so forth, right? So if I want to do 3 choose 2, let's say, I'd have to do, okay, this is 3 factorial all over 3 minus 2 factorial times 2 factorial. I have to figure out what that number is. But actually, as it turns out, you can just generate Pascal's triangle, and it will tell you the answer. So let me show you here. So to do 3 factorial, you just go to the third row. So this is the third row. I know it's technically the fourth row, but we're going to start counting at 0. We always start counting at 0 in mathematics and in computer science as well. So let's start counting at 0. 0, 1, 2, 3. This is the third row. And then I'm going to go to the second element. This is the 0th element. This is the 1th element. And this is the second element. Okay? I know technically this is the first, but again, we start counting at 0. So 0, 1, 2. Okay. So that's telling me that 3 choose 2 is equal to 3. I didn't have to do the computation. I know, and you can check this, that the answer is just going to be 3. That's great for small numbers, and it works for big numbers too. So let's say I wanted to do 5 choose 3. That's 5 factorial all over 5 minus 3 factorial, 3 factorial. Instead of doing that out, what I'm going to do instead is I'm just going to go to the 5th row. So this is row 4, this is row 5. Remember, always start counting at 0. 0, 1, 2, 3, 4, 5. Good. And I'm going to go to the third element. Third element is, let's see, 0, 1, 2, 3. This is the third element. The answer will be 10. Without doing the computation, I know the answer is already going to be 10. So that's really cool. That's Pascal's triangle. We'll talk more about it in subsequent classes, but one last thing I want to talk about. Why did I introduce this in the first place? It's because of the binomial theorem. Again, you're going to have classes on this later on, but I just want to go over it. So binomial theorem says that x plus y to the nth power will be equal to the sum from k equals 0 up to n of n choose k, x to the n minus k, y to the k. All right, what does this mean? Let's do an example. Okay, so let me use binomial theorem to figure out what is x plus y to the 4th power. X plus y to the 4th power is, according to the binomial theorem, so go back here, the binomial theorem says that x plus y to the 4 is, wherever I see a 4, I'm going to plug in an n. So I'm just going to say, actually I'm going to write out the binomial theorem. So it says that this is equal to k equals 1 to n choose k, x to the n minus k, y to the k. In this case, my n is 4. So wherever I see a 4, wherever I see an n, I'm going to put a 4. So this is equal to the sum from k equals 1 to 4 of 4 choose k, x to the 4 minus k, y to the k, right? So now I'm just going to do this out the way I would typically. So k equals, oops, I'm sorry, I actually made a mistake. This should be 0 here. As you can see from the way that I wrote the formula, this should actually be 0. You always start at 0 with the binomial theorem. Okay, sorry about that. Okay, good. Good. So now I'm just gonna plug in numbers. So my k is 0. I'm gonna plug that in. 4 choose 0, x to the 4 minus 0 times y to the 0 plus, now I'm done, so I'm going to increment. So now this is 1, k is equal to 1. 4 choose 1, x to the 4 minus 1, y to the 1. Now now we're at 2, k is equal to 2. Keep going. 4 choose 2, x to the 4 minus 2, y squared, plus 4 choose 3, x to the 4 minus 3, y to the third, plus, when do I end? I end at 4, so this is going to be my last element. Y to the 4, good. And now, I can actually expand this. So let me make this smaller. Great. Let me expand this out. So, I could figure out, okay, what is 4 choose 0? 4 choose 0 is 4 factorial all over 4 minus 0 factorial, 0 factorial. I could do that. That's going to be 4 factorial all over 4 factorial times 0 factorial is 1. So remember that 0 factorial is just 1. And now 4 factorial over 4 factorial is just 1. I could do that. I could do that for each and every single one of these guys. But what I could do instead is I could use Pascal's triangle. Pascal's triangle, if I generate it here, will tell me what those elements are going to be. So I'm going to generate it up to the 4th row. I'm going to generate 5 rows, but this is the 4th row. In our way of counting, this is the 0th, 1st, 2nd, and so on. So this is 0, 1, 2, 3, and 4. Okay. So 4 choose 0, the 0th element is 1. So this is going to be 1, x to the 4. So let me make that clear here. So this corresponds to 1. Okay? And then the next element, 4 choose 1, corresponds to this 4 here. Okay? And then the next element, 4 choose 2, will correspond to, so we're on the 4th row, 0, 1, 2. This is the 2nd element. Okay? I know it's the 3rd element, but we're going to count it as the 2nd because we start counting at 1. Okay. Okay, so I'm just going to keep plugging that in. So x to the 4th, y to the 0 is 1. 4 choose 1 is 4. X to the 3, y to the 1. And then 4 choose 2 is 6, x squared, y squared. Plus 4 choose 3 is 4, x to the 1, y cubed. Plus 4 choose 4 is, let's see, 0, 1, 2, 3, 4 is, it's going to be, oops, let me pick a different color. It's going to be 1. So that's going to be 1. X to the 4 minus 4 is x to the 0 is 1. Y to the 4. Okay. So if you want to simplify this out, this is going to be x to the 4th plus 4x cubed, y to the 1st plus 6x squared, y squared plus 4xy cubed plus y to the 4th. That would be the answer. Okay. And that's easier, in my opinion. That's way easier than multiplying out x plus y times x plus y times x plus y. Because remember our original question, x plus y to the 4th just means x plus y times x plus y times x plus y times x plus y. If I were to do that myself, I would probably make a mistake. But with the use of the binomial theorem, I can make my life a lot easier. Okay, so you're going to have a lot of examples of that in your next and subsequent classes. I wanted you to see it with me. Okay, so thank you very much. Well, I'll see you on the 10th.